I'm Taoxu from Chinese Academy of Sciences, and I'm really grateful to get to share with you today about access control work we did on Apache Spark, a popular big data computing platform. So let us start with seeing the security and privacy challenge with big data. As you know, the techniques about big data are developing very fast. Let's let's take a glance at the big data landscape of 2006 and 2020. There are lots of tools to collect data, to store data, to analyze data, etc. Just 4 years, many new tools have been developed. Uh, we were busy developing various tools, while without sufficient consideration about data security. Existing platforms have no flexible or practical access control function for big data analytics, and sharing data is currently becoming more and more common, which further threatens security. GuardSpark 2 Plus equips Spark with built-in access control, so that data confidentiality is improved. Spark has the ability to um, harness various data sources, provides structured and unstructured data analytics engines or APIs. This work is for structured ones. The primary stakeholders in the threat model include data owners, data users, and data management and sharing platform. Data owners share data with data users on the platform and make access control policy to ensure data confidentiality. Data users use that data to find intrinsic value by structured engines or APIs, but may access data with unauthorized data usage purpose. The platform restricts access to unauthorized data used according to access control policy from data owners. Our research goals are to propose a fine-grained PAAC model for ensuring the data confidentiality to effectively and efficiently enforce the model in Catalyst Optimizer for unified access control. The Catalyst Optimizer optimizes the data processing logic in application built on structured engines or APIs. Four stages in Catalyst: transformation, analysis, optimization, materialization. The module enforcement acts as a secure logic plan generation stage between analysis and optimization stage. The object in PAAC is another, if any, data object that could be referenced in a structured data model. It could be tables in relational databases, streaming data treated as a table, structured fields treated as tables in distributed storage systems, or local file systems, etc. So, fine-grained protection of data objects is supported at the column level, row level, and cell level. We also define data operation purpose and data processing purpose. The data processing purpose indicates the ultimate purpose of a data processing logic for a data object in a big data application. A data operation purpose is the purpose of an operation in the data processing logic of a query or a data analytic algorithm. We use five simple purposes to enforce PAAC in GuardSpark 2 Plus. Data operation purpose: carry, compute, retrieve, assist, and output. There are three steps for analyzing purpose automatically. The first is to obtain data operation purpose for each data object. We can obtain a pipeline from an application code or the logic pipeline in catalyst. The second is to analyze data operation along pipeline for each data object. A data operation purpose is determined by the operator or function. For example, the sum function and its input object exp1 determine data operation purpose, data operation compute purpose on the input object. For an operation with multi-purposes, we split the path so that its new data operation purpose is added to a new branch. After that, we can get a purpose analysis graph. Finally, we identify the highest priority data operation purpose in each path of a graph and label it as the data processing purpose of the path. The priority logically denotes the level of modification that operation would added to data object. This is an example about purpose analysis graph of expense. Each path is labeled with data processing purpose. The secure logic plan generation stage consists of 4 modules: data object recognition, purpose analysis, compliance checking, and compliance enforcement. Using the logic plan, the first 2 modules recognize data object and analyze purpose for data object. The compliance checking module finds fine-grained access control policy according to subject and object attributes, and make access decisions for recognized purpose. The ultimate its access decision is represented by a path bounded with allowed cells. To generate a secure logic plan, the last module forms the logic plan according to access decisions. The evaluation for GuardSpark 2 Plus mainly answers the 3 questions. Its overhead compared to original Spark, its scalability, does it provide unified PAAC enforcement for heterogeneous data sources and up-layer applications. The average overhead is 3.97%. With dataset getting bigger, the overhead tends to become smaller. The reason is that time producing secure logic plan is stable, while time producing a logic plan becomes longer with bigger dataset. In addition, obviously, the scalability of dataset size is consistent with Spark. As a policy, scalability is mainly determined by compliance stacking module. The time consumption of each rule in policy becomes shorter with larger rule set size. Even the rule set size goes up to 10,000, and the total time consumption is only about 3 seconds. This query is used to show the case study on SQL engine. The policy based from seeing sensitive data. The green font is sensitive data example. This data object is seen and while computed. Its secure logic plan uses a root the project operator shown in the dashed rectangle. The secure logic plan erased sensitive data. This figure shows the 3 different results of the query. They demonstrate those sensitive data cannot be seen, while right computing results can be good. For ML engine, when we test k-means, we use GuardSpark plus to ban some data from computing. That is, some points cannot be used by this algorithm. For a graph frame engine, we test PAAC and we conceal the most important person in the social network. For structured streaming engine, we ban some stream from computing. The above tests show that GuardSpark 2 Plus can work for all structured engines. The previous case studies involve the data sources LFS, HDFS network, streaming, and Kafka. We also test MySQL database. The results show that GuardSpark 2 Plus can work on this source. So, GuardSpark 2 Plus has the ability to provide unified PAAC enforcement for heterogeneous data sources and applications. This is the end. Thank you very much.